Alright, so this is our honors chemistry lesson video, and in the beginning we're just going to do a review of section 9.1 through 9.3, so that kind of gets you prepared for the 9.4 video. Alright, so remember, make sure you have a periodic table labeled. So in 9.1 we went over how to name regular metals, which are the pink ones. In 9.2 we went over how to name the elements that can have multiple charges, which include the transition metals. In 9.3, we learned how to name compounds that start with a nonmetal. And then in 9.4, you will learn how to name acids that start with hydrogen. Okay, so just make sure you have a periodic table colored like this to refer to. So let's go back to 9.1. So regular metals, those were the pink ones on my periodic table. So the regular metals include group 1 except for hydrogen, group 2, and aluminum. When you name a compound that starts with a regular metal, you name the first element and add I to the second element unless it's a polyatomic ion. And when you write the formula, don't forget to cross your charges. So let's look at a couple. So it says write the name or formula for the following. So AlBr3. So remember, I name the first element, so Al is just aluminum, and I add I to the second element. So Br is bromine, and so I will call it bromide. Remember, we don't use prefixes for compounds that start with a metal. Okay, so you don't need to call it tribromide. We only use prefixes for compounds that start with a nonmetal. So next one, sodium sulfate. So I need to give the formula. So don't forget you need to cross or balance your charges. So sodium is Na, it's in group 1, it has a positive 1 charge. Sulfate is on your polyatomic ion sheet, it's SO4 with a negative 2 charge. So I need to cross my 2 down. Okay, so that's what we learned from section 9.1. Alright, so maybe pause it, try these 4, and then we'll check them together. So I'm going to assume you paused it and tried them. Alright, so our first one, I'm going to name it. So Li is lithium. NO3 is on your polyatomic ion sheet. It is nitrate. And so remember, we don't change the ending of a polyatomic ion when we're naming ionic compounds that start with regular metals. Our next one, SrCl2. So Sr is strontium. You just name the first element. And Cl is chlorine, but I'm going to call it chloride because we changed the ending of the element. And remember, we don't need dichloride because this is an ionic compound, not molecular. All right, so hopefully you got those 2 right. So for the last 2, hopefully you remember to balance your charges. So we have barium oxide. Barium is Ba. It has a positive 2 charge because it's in group 2. Oxide is O. It has a negative 2 charge because it's in group 16. Positive 2 and negative 2 cancel, so you don't need to cross your charges. So it's just BaO. And last one, magnesium phosphate. So magnesium is Mg. It's in group 2, so it has a positive 2 charge. Phosphate is on your polyatomic ion sheet. It's PO4 with a negative 3 charge. Positive 2 and negative 3 don't cancel, so I need to cross my 3 down, and I need to cross my 2 down. However, this is a polyatomic ion, so I need to put it in parentheses. Alright, so like I said, everything right here sums up what we did in section 9.1. So let's move on to what we learned in 9.2. So in 9.2, we learned how to name compounds that start with a transition metal or other element that can have more than 1 charge. So remember, the transition metals are in groups 3 through 12. It includes that little triangle of elements up under the stair step, not aluminum, and it includes the lanthanides and actinides at the bottom. So when naming compounds that start with a transition metal or other element that can have more than 1 charge, you name the first element, add a Roman numeral for the charge, and add I to the second element unless it's a polyatomic ion. So this naming system follows the one we just did in 9.1. We just need a Roman numeral now to show the charge. When you write the formula, you still need to remember to balance your charges. Now, there is one new thing we're going to talk about because every now and then you'll see an old name for a transition metal. And so here's the old naming system chart. You have it in your packet a little bit larger so you can see it better. So remember, for the old naming system for transition metals, there's ic and us endings. The ic endings mean the higher charge and the us endings mean the lower charge. Now they don't tell us what the charge is. So like ferric is a positive 3, whereas ferrous is only a positive 2. But cupric is a positive 2 and cuprous is a positive 1. It's just the ic ending happens to have a higher charge. And they don't even have to be 1 apart. Like stanic is 10 with a positive 4 and stannous is 10 with a positive 2. I don't make you memorize this because it's the old naming system. I kind of just wish it would go away, like we've moved on to Roman numerals, but sometimes you'll see these, so I just want you to be able to understand how to use them. Alright, so it says write the name or formula for the following. So we have Fe2O3. So I know Fe is iron. And since it is in the transition metal section, I know I'm going to need a Roman numeral. And O is oxygen, which will be called oxide. So now we got to figure out what that Roman numeral is. So we don't know the charge of iron because it can have multiple charges, but we do know the charge of oxygen is -2. But I have 3 of them. So really that's -6 because I have 3 -2s. What cancels out a -6? A +6. But I'm going to split that between 2 atoms. So each atom would have a +3 charge. So 3 is what should go in as my Roman numeral. Alright, so let's look at our next one. So I gave you an old name, cupric sulfite. Okay, so again, you have this chart in your packet. So cupric means copper with a +2 charge. So if you see an old name, you can just look at your chart. So cupric means copper with a +2 charge. Sulfite is on your polyatomic ion sheet. It's SO3 -2. Since +2 and -2 cancel, I don't need to cross anything. So if you see, like I said, an old name that ends in ic or us, then just look at your chart to be able to tell which charge it has. Alright, so why don't you go ahead and pause it, try these. Don't forget, on this one I've asked for the old name. So once you figure out the charge, you might want to refer back to that chart. Sorry, I'll assume you paused it and tried it, so let's look at it together. So zinc 2 permanganate. Well, zinc is Zn. Remember, the 2 tells me the charge, not the subscript. So zinc +2. Permanganate is on your polyatomic ion sheet. It's MnO4 -1. So I need to cross that 2 down, but since this is a polyatomic ion, I just need to put it in parentheses. So hopefully you got that one right. Alright, for our next one, remember we want the old name. So I'm actually going to show you both names just in case. So for the old name, I can see it starts with copper, so I know I'm either picking from cupric, which is copper with a +2, or cuprous, which is copper with a +1 charge. Okay, so I'm going to do the normal name first. So we know it would be copper, Roman numeral, O becomes oxide. We just don't know what the Roman numeral is, which means we don't know the charge, so we just don't know whether we're picking cupric or cuprous. So we got to figure it out. Well, we don't know the charge of copper, but we do know the charge of oxygen is -2. So what cancels out a -2? A +2. But since I have a subscript here, I'm going to take those 2 positives and split them between 2 atoms, so they'll each be +1. So if I was getting the new, we shouldn't even call it new, the current name, I would call it copper Roman numeral 1 oxide. But since I've asked for the old name, now that we know it's copper +1, it would be, so here's my old name, cuprous oxide. So notice the old name does not have the Roman numeral in it. Okay, so the normal name would be copper 1 oxide. The old name, because copper does have +1, would be cuprous oxide. So if I had discovered that copper needed a +2 charge, I would have called it cupric oxide. So that was section 9.2, where we learned how to name compounds that start with an element, a metal, that can have more than 1 charge. So now let's move on to everyone's favorite, and that was 9.3, where you start with nonmetals. So the nonmetals are located to the right of the stair-step line on the periodic table. When naming compounds that start with a nonmetal, you use the prefixes to indicate the number of atoms, except when the first element only has 1 atom. And then don't forget to add I to the second element. When writing the formula, you actually do not balance charges because the prefixes tell you what the subscripts are. So the problem is, y'all, once I teach you about prefixes, you start to use them when you don't need to. Like you try to use them in the 2 previous types that I give you. You only use prefixes if the first element is a nonmetal. So let's look at a couple together. So we have N2O. So since my first element does have a subscript, I will need a prefix. My prefix for 2 is di, and N is nitrogen. The second element always needs a prefix. So since there's just one O, I'm going to call it monoxide. So don't forget to put that I in there. Monoxide. If I give you the name, you do not need to cross-chart it. So diphosphorus, phosphorus is P, di means 2, pentoxide. Oxide is O, it's just oxygen, and penta means 5. All right, so remember, this was the type that everyone liked. So why don't you try a couple just to make sure that not only do you like it, but you get them right. So y'all try these real quick. I'll assume you've paused it and done that, and we'll look at them together. So we have CO. There's only one C, so I don't need a prefix, so it's just carbon. And then there's only one O, which I'm going to call oxide, but the second element always needs a prefix. So I'm going to call it monoxide because my prefix for 1 is mono. Hopefully you got that one right. All right, our next one is CCl4. So the first element only has 1, so I'm just going to call it carbon. I don't need a prefix. The second one is chloride, and it does need a prefix, and it needs a prefix for 4, which is tetra. So carbon tetrachloride. So hopefully you got both of those right. Our next one is nitrogen trihydride. So nitrogen is just N. Since there's no prefix, I can assume there's only one. Hydride is just H. Oxide is O, nitride is N, hydride is H. It's just hydrogen. So since it's trihydride, I need 3 hydrogens. So it's NH3. And the last one is phosphorus trichloride. So phosphorus is P. Since there's no prefix, I can assume there's 1. Chloride is Cl. And since it says tri, I know that there are 3. All right, I think that's it for this section. Let me just double check. Yep. All right, so that was just a little review of sections 9.1 through 9.3. I do have the longer videos where I fully teach it, but this was just a little reminder to get you ready for section 9.4.